All right, we've made it. We are actually going to be solving rational equations. That shouldn't say expressions. So we're going to be solving these now, and because we have the skills, we know how to add and subtract, we know how to multiply and divide, and we know how to reduce them. So those are the keys that we needed to learn before we were ready to solve. We also know how to look for restricted values, which comes into play after you've solved. You need to verify that your solutions are accurate. So we're ready to get started on video 4. All right, so this is a review of solving, and what we're going to be noticing here is that there's a way to solve this by clearing the fractions. Rather than try to turn these all into fractions or with the same denominator, I'm going to clear the fraction by using the least common denominator. So my LCD, my least common denominator, what would clear all of my fractions would be a 6. So we multiply everything by 6. And in this case, it's 6 times 5/6x minus 6 times 2x plus 6 times 1/3 equals 6 times 2/3. As in, the 6 is being distributed to each of them. So the 6 is given permission to reduce with each of these pieces within the equation. So the 6 on the first part actually just reduces to a 5x because the 6's cancel. And in this next piece, the 6 gets multiplied by the 2, which makes it a negative 12x. And in the next piece, the 6 and the 3 become just a 2. And in this next one, the 6 and the 3 become a 2, but they get multiplied to be another 2. So, 4. And then we can go ahead and proceed to solve this using a linear method, and that would be negative 7x equals positive 2 when you subtract, and x equals negative 2 over 7. And since there's no x's in my denominator, this is an unrestricted value and we're good to go. So the idea was that we use the least common denominator and it reduces with each of the fractions within. That method is going to get applied here. I'm going to identify my least common denominator as x minus 4. That means that I'm going to multiply each piece by x minus 4. And when I do that, x minus 4 times the x that's already there, and the 4, and I'm going to multiply that one times x minus 4 over x minus 4, plus this 4 times that x minus 4, and there is no denominator, so you can write a 1 if you'd like. Oops. Well, no, that's fine. So what happens is that this x minus 4 cancels and you get an x, and this x minus 4 cancels and you get a 4, and this one doesn't cancel, so you get 4x minus 16. Now, I am allowed to cancel. You can cancel denominators or clear denominators only when solving. Please notice that this is the 4th video. This is the 4th video, and it is the first time that I've gotten rid of denominators. So when I ask you to add or subtract or multiply or divide, you cannot get rid of denominators because we're not solving. That's changing the value of a fraction. Here I am solving. I am using clearing the denominators as a method of solving. So it's very different. You can't just see denominators and just start canceling them. That doesn't work. Okay? That's like saying 2/3 plus 4/5, and when you go ahead and multiply by 15 as your least common denominator, you're just going to get a 2 and a 4. No, 2/3 and 4/5 are not equivalent to 2 and 4. So you cannot just clear. Now, if I was solving this and I had an x and I had something like this, then I can clear the fractions. Very different. Adding and subtracting versus solving. I'm making a big deal out of that because I'm introducing something and it doesn't mean it fixes everything in the entire unit. Okay, so I'll reiterate that as we keep going. Let's go ahead and continue to solve. X equals, in this case, negative 12 plus the 4x. I'm going to subtract that 4x over, and I get x to equal positive 4. And I think this is awesome. I got to the bottom, I got my answer, I'm going to circle it and move on to the next one. However, x equals 4 is actually the only value that x was not allowed to be. So if you come up to a situation in which the solution you found is actually the restricted value, this has no solutions. No solutions. Let's go ahead and take a look at the next one. Alright, so this next one, my least common denominator, must represent the 4 and the x plus 1. So I'm going to multiply each of these pieces by a 4 and an x plus 1. What I notice is that this one, this first piece, that the 4's would cancel. So it's really just x plus 1 times 4x plus 3. And in this one, when we multiply it by 4 times x plus 1, that the x plus 1's would cancel. And that just means it's minus 8x, 2x times 4. And don't forget the subtraction sign. And this last one, when I multiply it 4 times x plus 1, nothing cancels because there was no denominator. And that leaves me with 4x times x plus 1, multiplying the 4 times the x and then the quantity x plus 1. I'm going to have to multiply everything out here in order to decide if I can solve it and continue. So here I have, if I multiply these out, I get 4x squared, I get a 3x, a 4x, and a 3. So 4x squared plus 7x plus 3 minus 8x equals 4x squared plus 4x when I distribute. So this one required me to multiply it out and distribute it all, and this was just a simple distribution. I'm going to combine like terms, and that leaves me with 4x squared minus x plus 3 equals 4x squared plus 4x. When I subtract the 4x squared to the other side, I end up eliminating the quadratic part of this, making it a very nice linear problem. I'm going to add the x to the other side, leaving me 3 equals 5x, and x will equal 3/5 when I divide by 5. Make sure you're dividing the correct way. I need to go back and decide, was x allowed to be 3/5? And in fact it was. So this is my solution. Let's try another one. For this one, I'm going to just go ahead and start factoring in order to determine my least common denominator. And so for this, I have x plus 2 and an x minus 1. Here I have x minus 1 and x plus 1. So this is why factoring is so important, because they're going to take me a long time if I'm not very confident with my factoring. In the last one, I see that they all can be divided by 2. And then I have x squared plus 3x plus 2, which is a lot nicer to factor, to x plus 2 and x plus 1. So scanning the entire denominator, my least common denominator, I must represent the 2 that's in the last piece. I must represent an x plus 2. I must represent an x plus 1 and an x minus 1. So this is my least common denominator. It's not simple. It's 4 different pieces that must get represented. When I go to multiply each of these pieces, the 3 over the fraction, the negative 1 over the fraction, and the 7 over the fraction, I only have to consider the pieces that were not in the original denominator, because the ones that were in the original denominator will cancel. Similarly, if I had a 3/5 and a 2/3 and I was multiplying by 15, the 5 and the 15 would reduce, and it's really as though I'm only multiplying it by a 3. And the 15 here would reduce, and it's like I'm only multiplying it by the 5. So you're actually only altering the numerators by the pieces that were not in the denominator of the original fraction. So this first one needs to be multiplied by the 2 and the x plus 1. So 3 times 2 times x plus 1 is 6x plus 6. And the other pieces in the denominator would cancel. In the next one, I need to multiply it by the 2, so it's a negative 1 times the 2, and I need to multiply it by the x plus 2. Remember, you're distributing here a negative 2, so that's minus 2x minus 4 equals, And then here I'm going to multiply it only by the x minus 1 because that's the only thing that was not included in the denominator. So I get 7x minus 7. You're thinking, where did my denominators go? And if you're thinking that, remember that we just canceled the denominators with the other pieces that were part of my least common denominator. So I'm taking this large rational equation and simplifying it and clearing the fractions so that I have something much more comfortable to work with. This leaves me with 4x plus 2 equals 7x minus 7. I'm going to add the 7 this way and subtract the 4x this way, and I will get x equals 3. I do have to go back and make sure that none of the areas would cause an issue if I substituted in a 3. And it will not, because my restricted values were that x could not be a -2, a +1, or a +2. So 3 is perfect, and that is our answer.